In this video, I'm going to discuss how we can use reference angles, at least reference angles of special angles, so like 30s, 45s, and 60s. But if any angle has a reference angle that's a special angle, we could use those reference angles to help evaluate the value of that trig function. Okay, so to intro this, we're going to take into account this example up here. We say find the cosine of an angle theta given that 3, 4 lies on its terminal side. So for instance, we say, well, I know the point 3, 4 lies on its terminal side. 1, 2, 3, 1, 2, 3, 4. So we'd say, okay, well, we are aware that my angle theta, whatever it is, I don't know what the angle is, but certainly that this point 3, 4 lies on its terminal side. And we can clearly see our, we want to zoom back out, I would hope. Let me zoom out here. Sorry about that. Must have clicked off my pen tool here. Okay, but we know the point 3, 4 lies on its terminal side. So if you want to consider this, we know that this right triangle exists. We know some dimensions of it. We know this is 3 and we know this is 4. We could use Pythagoras to determine that this was 5. But we said, let's go find the cosine of this. Recall that the cosine of an angle, if we know a point on the terminal side, is x over r. And so in this instance, we say the x value is 3 and the r value is 5. So cosine is positive 3/5. What I'd like to do instead this time is find the cosine of an angle, another angle here, given that negative 3, 4 lies on its terminal side. Okay, so if we were to graph this point, negative 3, 4, go left 3, up 4, we could see that this point would be here, and our angle this time would actually terminate in quadrant 2. It wouldn't terminate in the first quadrant. And the thing that's convenient about this angle is that you can see your right triangle here. You can see that it has sort of the same dimensions except for our x value happened to be negative. Well, will this affect the situation? Well, when I label my triangle, I'm going to call this side negative 3. I'm going to call this 4. And of course, r is still 5. What I want you to see is these are the same triangle, the same exact triangle. The only difference is that the angles are different, okay? So what I want us to recognize is this. The whole point of this video is how we can use reference angles to find the value of a trig function. Basically, let's start with this. The reference angle for this triangle on the right over here, recall that a reference angle is formed between the terminal side of my angle, and the x-axis. So if we were to look at this reference angle right here, we often call it not theta but theta prime, you'll notice that its reference angle is the exact same thing as this angle over here, which basically implies this: you're dealing with the same right triangle. The only difference is going to be this. If we were to do the cosine now of theta in this triangle over here, you'll notice that it's x over r still, but we get negative 3 over 5. And the reason that this happened is because we were in the second quadrant and x values are negative in the second quadrant. So here's the cool thing about it. I can promise you something. If two angles have the same reference angle, look at this. Let's go back to the red ink here. They have the same reference angle. They have the same reference angle. What I can tell you is the value of cosine, they're going to have the exact same values. At least they may not have the same sign, S-I-G-N sign, but they have the same values. And the reason why is because we were dealing with the same triangle. So once we discover this shocking revelation, basically what we could come to the conclusion, which conclusion we can come to is this. When we evaluate the trig function of an angle, we could really just evaluate the trig function of its reference angle instead, because you're going to get the same number anyways, and then we'll just call cosine negative. And the reason why I know cosine is negative is because if you watch my last video, we say all students take calculus. We could say, well, looking at this, we say sine is the only thing that is positive in the second quadrant, and this terminated in the second quadrant. We were finding cosine, so cosine must be negative. So here's the deal. Why would I want to, instead of, evaluating the trig function of an angle, just like I should, with x over r, say in this instance, why would I want to use its reference angle instead? Well, the beautiful thing about reference angles is they're always positive, and they're always acute. And I should have memorized the cosine, the sine, or the tangent of 30, 45, and 60 because they deal with our right triangles, or at least our special right triangles. So we're going to fill out this table over here on the right. We say, all right, well, if I had a 30, 60, 90, or a 45, 45, 90, we know in a 45, 45, 90, we say the short legs are AA and the hypotenuse A radical 2. Or in a 30, 60, 90, we know the short leg is A, hypotenuse is 2A, and that this is A radical 3. But this could help us find, the sine, cosine, tangent of these special angles here. Okay, so for instance, we'll do 1 or 2 written out, and then we'll just fill in the rest of the table. But for instance, if I wanted to find the sine of 30, you can see your 30-degree angle up here. We say sine is opposite over hypotenuse. We get A over 2A, but we end up with just a half. Okay, or say for instance I wanted to do the sine of 45. We'll go over to my other special right triangle here. We say 45. The sine of this would be a over a root 2. We say a over a root 2, which is just 1 over root 2 once we kick out the a's, and we get this as the root 2 over 2. So we say root 2 over 2. And if we were to do lastly, you say sine of 60. We have to go back up here to our 60-degree angle, but we say opposite, which is a root 3 over the hypotenuse, which is 2a. You can see that the a's kick out and we just get left with this root 3 over 2. The point I want to make here is this: when you do your sines, it's cool. They're all over 2 and they go in order. They go 1 on top, radical 2 on top, radical 3 on top. And if you were to go back into your cosines, they're actually in the exact opposite order. So I'm going to say starting today, everybody is tuning into this video needs to actually just memorize this relationship. Start by memorizing your sines from 30, 45 to 60, and then just know that cosines are backwards. As far as tangents go, I could let you find them on your own. I will point one out that you should memorize. The tangent of 45, you look at your 45, it's opposite over adjacent, or a over a. You always get 1. Let's put that in blue. 1. And we say, well, these other two, we just need to memorize these. Radical 3 over 3 and root 3. What I want to do is I want to use reference angles to evaluate the trig function of any angle. And we say any angle that has a reference angle that's any of these. We're going to be able to do it very easily because we have these values memorized. So here's going to be the steps that we go through in our process. We say 1, find the reference angle for the angle that you're dealing with. Of course, I'd rather deal with a reference angle. Why? Ref angles are positive and acute. We're very good at positive acute angles. Here they are right there. Okay. And then we're going to rewrite the original trig function, but instead of using the original angle, we use the reference angle. After that, we'll affix or put in place the appropriate sign to the trig function. That is, should it be a positive or negative? And we're just going to assess this using what quadrant it terminated in, because we have this mnemonic here that says all students take calculus. I could tell you easily whether it should be positive or negative, and then we'll just evaluate the trig function. So we'll just go ahead and start with this one down here. We say sine of 135. How would I do this? Okay, well, the first thing I would always recommend is sketch out the picture. And 135 degrees, is roughly right here. We say, here's my angle, theta, and it's 135 degrees. What I want to do instead is find the reference angle. And of course, the reference angle is this angle right here. In this case, we say the reference angle, theta prime, is, let's see if I can squeeze this in here, 45 degrees. So step number 1 says find the reference angle. We're going to write this down. Reference angle is 45 degrees if my original angle's 135. Step 2 says rewrite the original trig function, but instead we'll use the reference angle. So instead of doing sine of 135, if I were to do the sine of 45 instead, look at this, you get the same triangles. So they have the same measurements. We're going to do instead the sine of its reference angle. Why? Well, because I know the sine of 45. Look up here, it's right there. I can memorize this, okay? So step 3, where it says affix the appropriate sign to the trig function, plus or minus, depending upon what quadrant it terminates in. Essentially what it's saying here is that you're finding sine. And sine in this case terminated in the second quadrant. So using our mnemonic here, all students take calculus, we know that sine in the second quadrant should be positive. So out front, I'm just going to write a big fat positive sign. And then the last step here says evaluate the trig function. In other words, positive what? Well, what is the sine of 45? We say root 2 over 2. So here's what I'm going to tell you. If we had found the sine of 135 to begin with, we would have gotten this value. Well, at least we know we would have gotten root 2 over 2 because 135 has the same reference angle as 45. And so looking at the picture here, they make the same triangle. So they get the same sine values. It's just that in this case, it's positive root 2 over 2 because it terminated in the second quadrant. So we're going to keep running with this here. We say 5 pi thirds. Well, recall that pi is the same thing as 180 degrees. And so a third of pi is 60 degrees here. So if we had 5 60-degree angles, we say this is a 300-degree angle here. So let's go ahead and start by doing what we did last time. We say sketch the angle. A 300-degree angle would terminate down here. We say here's my 300-degree angle. First thing we're going to do is this. We're going to find the reference angle. In this case, the reference angle, 60 degrees. So we're going to write this down. We say theta prime, 60 degrees. So instead of doing cosine of 5 pi thirds, we could instead now rewrite this as saying, well, it's just got to be the same thing as cosine of 60 anyways. Why cosine of 60? Because I know the cosine of 60. It's right here. It's a half. But here's the deal. We say, should this be positive or negative? Well, I'm looking at this. We say all students take calculus. It terminated in the fourth quadrant, and we're finding cosine, and cosine is positive in the fourth quadrant. So I get positive cosine of 60. In other words, I get positive, well, what is the cosine of 60? It's a half. Why? Because because I have that memorized, or at least I should be memorizing this. So we're going to run through a few exotic angles and be done with this video. But we say a negative 780. I'm going to pull this one out over here. A negative 780, let's think about this. I'm going to be spinning clockwise. I'm going to go at least 360 degrees here. So if I were to say, for instance, get my calculator out here. If I were to say 780 minus 360, I still have another 420 to go, which is still another 360. If I take a 360 off of that, that's another 360 plus another 60. So we say, another 360 plus another 60 that terminate right here. So here's our negative 780 degree angle. You can see how this wouldn't be something that I'd be interested in doing. What I'd rather do is say, well, what's the reference angle? And of course, the reference angle here, looks to me to be a 60 degree angle. So we say tangent of negative 780 instead, we'll just do this. It's tangent of 60. It's going to be the same thing anyways in terms of its numerical value. Should it be positive or negative? Well, given that we're finding tangent in the fourth quadrant, the only thing that's positive in the fourth quadrant is cosine. So we're going to call this one actually this time negative. So we say negative tangent of 60, and we say, well, what's the tangent of 60? Looking up here, we say, well, it's this root 3 value. So we get negative root 3. So to find that would be the same thing as to find the value of the original in the first place. It's just easier using reference angles because these angles are easier to memorize and deal with. So let's do 3 more here. We say cosecant. What if I wanted to find a reciprocal trig function? Cosecant of a negative 11 pi 6. Okay, recall that a pi is 180 still, so a sixth of pi sixth is 30, and I have 11 of those angles. So we'd say really this right here is the cosecant of negative 330 degrees. So we're going to start by sketching. So I say sketch. Here's my negative 330 degree angle right here, clockwise, negative 330. What's the reference angle? Well, my reference angle right here is 30. Let's just do its reference angle instead. So let's rewrite this trig function. Instead of doing cosecant of this, we'll do cosecant of 30, because I could do that instead. And we say, by the way, should this be positive or negative? Now keep in mind 2 things. One, if I wanted to find the cosecant of 30, the first thing I'm going to have to find is the sine of 30. And 2, if sine is positive or negative, then cosecant is positive or negative. So to determine whether cosecant should be positive or negative or not, then what you really need to look at is this: is sine positive or negative in the given quadrant that it's terminating in? And right now it's quadrant 1 that it's terminating in. And we say, well, all things are positive up here. So if sine's positive, cosecant's positive. So we'll put a big fat positive out in front of this. So to find the cosecant of 30, and in essence to find this here, we say it's positive cosecant of 30. So we're going to have to find the sine of 30 first. So we get positive, sine of 30 is a half. So if I want the cosecant of 30, it'd just be the reciprocal, 2 over 1. And in this case, positive. So 2 more we'll get through here. We say secant of negative 240. We'll go ahead and sketch her out. Negative 240, that'd be clockwise. We'd say 180 plus another 60. That'd be about right here. Here's our negative 240. Really all we care about is what's the reference angle. Well, that's a reference angle. And in this case, our reference angle, if you think about it, is 60 degrees. So we're going to rewrite this, and we're going to say, well, really instead I'd rather do secant of 60 degrees because I know I get the same number anyways. Oh, and by the way, should this be positive or negative? All students take calculus. Well, the only thing that's positive up here is sine. And we're finding secant, which is the reciprocal of cosine. So cosine's negative. Hey, guess what? This is negative. So to find the secant of negative 240, we'll instead find the negative secant of 60. Oh, and by the way, this means we're going to have to find the negative cosine of 60 first and then reciprocate it. Well, if cosine of 60 is one of the ones I should know, cosine of 60 is a half. So we get negative a half for the cosine here. Then we'd say the original value here, sorry to be all over the place here, but it's equal to negative 2 over 1 because it is the reciprocal of that. And last but not least, cotangent of negative pi thirds. That's the same thing as cotangent of negative 180 degrees divided by 3. In other words, cotangent of negative 60 degrees. So we say, all right, sketch it out. Negative 60 is right here. Negative 60. We say, what's the reference angle to this? Well, the nice thing about a negative 60 is this. 60 degrees is theta prime. 60 degrees. So instead we'll do this. We'll do the cotangent of 60 since it's going to be the same number anyways. Oh, and by the way, if I want the cotangent of 60, I'm going to have to go find the tangent of 60 first and then reciprocate it. And the tangent of 60, if we look up here, is root 3. So we say root 3. Oh, by the way, I suppose we better find out if this is positive or negative. All students take calculus. Cosine's positive in the fourth quadrant. Everything else is negative, so all these cotangents will be negative. So we get this. Going to the left here from my tangent here, we get negative root 3. So if I'm going to reciprocate this, I'll put it over 1. And we say the original thing up here is negative, and then 1 over root 3, which, by the way, if you rationalize, you get negative root 3 over 3. So sorry for the mess in this whole video, but that is how you use reference angles, with at least special angle reference angles, to evaluate trig functions of things that have really weird angles. So cheers.